The next type of energy that I want to talk about is potential energy. Potential energy is energy that is stored in a system. It could be chemical potential energy that is, the chemical could be rocket fuel that is stored in a rocket. It could be the potential energy in a slingshot that you're pulling back, that elastic potential energy that is stored in a slingshot. Or it could be simply gravitational potential energy, which is the energy of position, which is if I'm holding this marker up a certain number of meters over the floor, it has the potential to fall and do some damage, right? So it has a certain potential, gravitational potential energy. So we have got gravitational potential energy. We have chemical potential energy. And we've got elastic potential energy. Let's talk a little bit more about gravitational potential energy right now. So when I introduce a new concept like this, there's always a formula that goes along with it. Gravitational potential energy we'll abbreviate as GPE, and it's equal to mgh. M is for mass, as usual, and h is for the height above a zero reference line, which is usually the ground. G, little g, you'll remember, is 9.8 meters per second squared. Let's calculate the gravitational potential energy of this marker being held above the ground, 1.5 meters above the ground. And let's say the mass of the marker is, I don't know, 0.01 kilograms. So m is equal to 0.01 kg. Gravity is 9.8 meters per second, and height above the ground is 1.5 meters. Let's go ahead and calculate this. So GPE is equal to 0.01 times 9.8 times 1.5. I got 0.147. 0.147 what? 0.147 joules, yes. The units for gravitational potential energy are the same as they were for kinetic energy. Joules, right? Now you can imagine other types of problems where I may ask you to solve for the mass and for the height. I probably would never ask you to solve for g, but again, that's be just algebraically manipulating these equations.